Good afternoon, everyone, and welcome to the November 19th edition of ICLR's Friday Forum. My name is Mark Elliott, and today I have the honor of introducing Dr. Katsuichiro and his presentation titled Quantifying Financial Risks for Canadian Homeowners Using Earthquake Catastrophe Models. Dr. Goda is an associate professor and a Canada Research Chair in Multi-Hazard Risk Assessment at the University of Western Ontario. His research is focused on catastrophic earthquake-related multi-hazard risk management from economic and societal viewpoints. He has received international recognition on his high-quality research through various awards and grants, including a prestigious 2012 Charles F. Richter Early Career Award given by the Seismological Society of America, and a Humboldt Research Fellowship Award for experienced researchers by the Alexander von Humboldt Foundation. He has also received the 2017 IASSAR Early Achievement Research Award given by the International Association for Structural Safety and Reliability. Now, before I hand things off to Dr. Goda, there are a few notes to be aware of for today's session. You can submit your questions at any time during the presentation to the designated Q&A chat box on the Zoom interface. These will be answered in a dedicated question and answer session immediately following the presentation. If you're experiencing any technical issues during the presentation that you would like us to be aware of, please use the general chat feature. And with that bit of housekeeping out of the way, I'll now hand things off to Dr. Goda. Take it away, Katsu.
Okay, thank you, Mark. So hope everybody can hear me. My name is Katsuichiro from Western University, and I'm very happy, and it's my pleasure to give this talk because the last time I gave this Friday Forum talk was 12 years ago, and I was still a postdoc fellow at the Western University. So since then, I have worked on several interesting things, and then today, hopefully, I can share some of the things I found with you through this presentation. So the title, as it shows, is the quantifying the financial risk for Canadian homeowners using the earthquake catastrophe model. And then this kind of thing kind of started with the support from ICLR, especially the Paul Kovacs, and then he allowed me to use some of the insurance data through CatIQ database. And then since then, I had such a fun time to do a lot of research working with other collaborators, such as the famous economic behavioral economist, the Professor Howard Conluser, and so on. So hope you would enjoy some of the talk, some of the topics I mentioned today. So in this presentation, I want to touch on two problems. So the first problem I want to talk about is the earthquake insurance gaps for Canadian homeowners. And then the second one is the catastrophic earthquake risk, more regional side, and then how this current earthquake risk in Canada, mostly focusing on the eastern side of Canada, and how this risk sharing works. So just to set up some sort of scene, I just want to briefly introduce 3 slides to mention my motivation in setting up those two problems. So the first one is that, of course, the earthquake hazard and then the risk are a bit remote for Canadians, because we don't necessarily experience this kind of disaster frequently. But time to time, we had significant events if we go back hundreds of years. So the Insurance Bureau of Canada, for example, commissioned a study to do the risk study, one in British Columbia and another in Quebec. And then this study found that the $75 billion loss can happen if significant earthquake happen in BC close to Vancouver. And on the other hand, if the large earthquake happens in eastern Canada, north of Quebec City, then $60 billion of loss might be expected. And then to put those $75 billion and then $60 billion in perspective, just want to mention that the GDP in Canada annually is about 1.6 trillion. So it's about 5% loss can be caused in a single event, even in Canada. Yeah. So those are the location. You see that the Vancouver area, Victoria is here, and there's a lot of buildings and people live in this area. And in the Quebec, we have a St. Lawrence River. And then this is geologically kind of weak location in a sense that it's kind of geological rift region. So there's a lot of deformation is happening in this region. And if the earthquake happen, and especially the soil condition is not ideal, soft sediment because of the major river beds, the significant site amplification might happen, and then the loss can be significant. Also, through the analysis of insurance data, which I'm going to show today, the earthquake insurance is not purchased evenly across Canada. And then earthquake insurance is important because the money funds are provided by after the earthquake from the insurance industry can be used for the recovery and then the better building back better kind of resilience action after the earthquake. So, but the catastrophic earthquake exists, as I pointed out in the last slide. And then, but this catastrophic earthquake risk might be perceived somewhat differently because it might be considered to be a bit remote risk for general public. And then that depends on the historical events in the region, or the public awareness, or the personal experience, and so on and so on. So perceived risk may not be proportional to exposed hazard and risk. So that's my kind of starting point of my investigation. And I just wanted to more systematically compare what would be the behavior we see in purchasing the earthquake insurance, and then also what would be the exposed hazards and risk based on the scientific findings. So that's kind of the motivation that I had in studying this research. And then if we look at the insurance data, we can see that the homeowners in BC protect themselves from earthquake risk. So in Victoria and in Vancouver area, 50 to 70% of homeowners purchase earthquake insurance coverage. On the other hand, only 3 to maybe up to 4 or 5% of homeowners in Quebec currently purchase earthquake insurance. And then another things I just want to touch on before we start the main part of the presentation is the systemic risk for P&C, property and casualty industry. So the systemic risk and then also the regional seismic risk is important because if the huge earthquake happen, several tens of billions of dollars earthquake happen, then that might kind of overwhelm the capacity, financial capacity of the P&C industry in Canada. So the PASIC, for example, evaluates the systemic risk due to catastrophic loss to the P&C industry. And then based on their assessment, the tipping points that the PASIC, the whole industry start to collapse financially might be estimated to be about $30 billion loss to the P&C industry. So, so I just want to point out that this $30 billion might be a kind of important figure in looking at today's presentation. So if $30 billion happen to insurance industry, then the insurance industry as a whole might not be able to cope with that level of financial risk. And then some of the insurers may experience difficulty to financially pay off the debts, compensation to be paid. So those things in mind, I just want to start with my first topic, which is on the earthquake insurance gap problem, focusing on the homeowners. So to investigate this insurance gap problem for the homeowners, I started with looking at the 4 different data sets. First one is the 2016 census data, which is publicly available. So this would give us the information about the population, dwelling house type, etc., which is great information, source of information. And the second set of data set which I looked at was the Cat IQ insurance data, and then this data provides that how much insurance coverage was sold, policy was sold at the given FSA. FSA is a forward sortation area, as in census geographical region. So the FSA corresponds to the first numbers and digits, first 3 numbers and digits in the postal code. Yeah. And then from this data set, we can look at the fire insurance coverage and also the earthquake insurance coverage, so that we could estimate what would be the take-up rate for earthquake insurance coverage. And then thirdly, I looked at the information, publicly available information from Geological Survey of Canada's seismic hazard map at the building design, seismic design code level, which corresponds to the return period of 2,475 years, which is the 2% in 50 years exceedance level. So I've taken this publicly available hazard information, and I also wanted to compare the take-up rate at the given FSA location with respect to some sort of risk indicator, financial risk indicator. So to calculate that, I have developed my own earthquake catastrophe model, and then based on that, I have calculated annual expected cost, so the pure premium for the insurance coverage for typical Canadian houses or the household. And then I systematically compared the take-up rates with respect to annual expected loss ratio at the FSA level, just to see that how those different quantities are related spatially. So in doing that, I had looked at the entire Canada. Based on the census divides or census defines 1,620 FSA across the entire Canada. So those locations are shown, but specifically I focus on the province, the 2 provinces. One is BC, and then the other one is Quebec. So one in west, and then one in east. And then the west, we have Cascadia subduction zone. So there's the several plates, seismotectonic tectonic plates meet each other. Therefore, the seismic activity in this region is very active. On the other hand, as I mentioned, along the St. Lawrence River, there is a significant major seismic activity. And then the 3 major cities, Ottawa, Montreal, and Quebec City are located along the St. Lawrence River. So there's a high risk in this region. So as a start, I started looking at the census data. And then I just wanted to check that how at the FSA level, how the populations are distributed, and then how the number of dwellings, household are distributed. And then for this investigation, I was interested in mostly for the homeowners. So I selected out of 1,620 FSAs, I selected 1,058 FSAs where the majority of the households are single detached houses. Yeah. So, and then the population density is not too high. So I selected this the rectangular zone. The FSA falling into this rectangular zone is selected for my analysis, so which is about 2/3 of the all FSA in Canada. Then the census data also give us a lot of additional information. So I just, before I start other investigation, I wanted to check that the given FSA, whether the median, the income level might be similar or dissimilar, and also household age would be similar or dissimilar. So those information are available. So I checked that for 3 regions, BC, Quebec, and then all the others. And then I found that more or less the demographic features are similar. So I consider that there's no kind of discriminating factors that leads to the different economic behavior related to earthquake insurance purchases. Then I looked at the Cat IQ data and then also the census data. So the first figure is a scatter plot, which shows on the x-axis the number of dwellings from the census data. And then on the y-axis, it shows the number of fire policies sold. So you can see that of course, there's a scatters around the one-to-one line here, but the number of dwelling in the census and in the number of fire policies sold based on the Cat IQ data aligning on this one-to-one ratio. So this gives me an idea that the most of the household buy fire insurance. So then I looked at the same kind of data set, but focusing on the earthquake insurance policy, which is shown on the right-hand side figure. So again, x-axis is the number of dwelling from the census data, and then the y-axis is the number of earthquake insurance policies sold, as in Cat IQ data. So then we see the very different behavior. The characteristics in data, and especially for BC, some of the FSA come relatively closer to this one-to-one ratio, which means the 100 take-up rates, 100% take-up rates. But especially in Quebec, we don't see, or we essentially the FSA, the FSA in Eastern Canada, Quebec, do not buy earthquake insurance coverage. And then this can be shown in a different format. This is just the cumulative distribution plot of the same data set which I had. So again, in Quebec, hardly only 3% of the household buy the earthquake insurance coverage. On the other hand, we see the two bimodal situation for BC. So the people living in a mountain area don't buy, I believe, because they have less seismic risk or seismic hazard. On the other hand, people live in near Vancouver and Victoria area, where close to the subduction zone buys about 50 to 70% of the people buys this earthquake insurance. So that's the point here is that there's a difference in purchasing behavior from the residents in East and the residents in West. Then I wanted to calculate the pure premium, expected premium for homeowners. For that purpose, I looked at I developed the Catastrophe model, which is essentially a computer model, which combines the exposure data set and the seismic hazard data set, and also the seismic vulnerability data set, and we integrate those uncertain components, and come up with the so-called seismic risk curve or the exceedance loss curve. And then from that results, we can obtain we can calculate the financial risk metrics such as expected cost, expected seismic cost, or the value at risk, or any other quantities. So I have developed the earthquake catastrophe model for single-family wooden houses in Canada. That's my research expertise. And then I apply this developed model to calculate the expected premium. And then, so through this analysis, I can calculate for each FSA what will be the pure premium expected annual seismic loss for typical residential household. So just to give a little bit more information, a bit more visual way, in this calculation, I have considered the seismic hazard at the given particular location. This is the case for the Victoria, and then I have applied some statistical tools to come up with this seismic hazard curve at the given location. And then I combine that information with the exposure data set we have from the Cat IQ data and also the census data for each location. And then I have developed the seismic vulnerability model through structural earthquake engineering technique, and then doing a lot of analysis. I'm not going to touch on that. And then based on that, I have developed seismic vulnerability curves for the Canadian wood frame houses. And then I integrate this hazard and then the exposure and then the vulnerability into one to obtain for each location. I have calculated the exceedance loss curve, and then from there I can calculate the pure premium. And then the seismic vulnerability model are based on the shake table test results developed by the Professor Carlos Ventura at the University of British Columbia. And then the parameters, I believe, is one of the best results obtained so far for typical Canadian houses. So we have used realistic as the best type of results from engineering sense. So, but although we use this available, more sophisticated test results from shake table test at the UBC, it's always good to check whether this vulnerability model, analytically developed vulnerability model, would be realistic or not. So just to give some idea about the comparison of the developed vulnerability model with respect to the actual loss experience for the similar types of buildings, I show here the comparison against the loss model developed by Wesson et al. For the 1994 Northridge earthquake in the USA. So this Wesson et al. Study had access to about 80,000 insurance claim, earthquake insurance claim for 1994 Northridge earthquake. And then they have developed the statistical model for this loss experience. So here I have compared my 4 different models which I developed for this Canadian houses with respect to the seismic loss model developed by the Wesson et al. Based on the 1994 Northridge earthquake loss experience. So in comparison, I found that the house 4 and house 3 model, which represent the typical Canadian house construction, which doesn't have the seismic proper seismic design implementation, would correspond roughly to this Wesson et al. Curves. So you can see that some good correspondence of this gray line with respect to houses 3, 4, and 3 here, the black and then the green lines. Yeah, at the loss level of 10%, 30%, and 60%. So with this comparison, I was a bit more encouraged that okay, well, what I have developed is more or less realistic with respect to actual seismic loss experience in USA. So moving on, now I have be able to calculate for each FSA pure premium, and also I can obtain the peak seismic design peak ground acceleration (PGA) from Geological Survey of Canada's database. And I'm just showing here the scatter plot of the design PGA against the annual expected loss ratio, which I calculated for different FSA in Canada. So we see that the different behavior in Quebec and then the different behavior in BC. And then this difference can be explained from the seismological perspective that the BC seismic events tends to have more richer, longer vibration period wave components, and that would inflate the losses with respect to Eastern Canada type ground motion. So my point here might be the peak ground acceleration might be a useful hazard indicator, but if we want to compare the take-up rates against the risk indicator, then it might be better to use annual expected loss instead of seismic peak ground acceleration. So now I have all the results ready for comparison. So I compared the three quantities, earthquake insurance take-up rates obtained from CatIQ database. And then the second one is the seismic design peak ground acceleration from the National Seismic Hazard Map by GSC, Geological Survey of Canada. And then the annual expected loss ratio, which I calculated from my own catastrophe model. And I can show this on map, or I can show this as a scatter plot just to check the trend of those maps or the quantities. And then after that, presenting those results, I would like to discuss a little bit about possible solution to close this insurance gap. So as you see three different hazard map, or three different maps. The top figure shows the earthquake insurance take-up rates calculated based on CatIQ dataset. And then the second map shows based on the GSC's seismic design peak ground acceleration. And then the third one shows the based on the CAT model based the annual expected loss ratio for each FSA. So it's obvious from the top figure that in BC, especially in the Vancouver Island, people buy earthquake insurance. On the other hand, the people in Quebec along the St. Lawrence, people don't buy earthquake insurance. Then in the second map, we see that the hotspot, the high seismic region in Vancouver Island, and also along the St. Lawrence River. So the public seismic hazard map indicates that the seismic hazard in the Eastern Canada is not negligible. And then the loss calculation based on my model would also show that the high risk in BC, and then some high risk in the north of Quebec City, and then a moderate risk here in Montreal and Ottawa. So my point of this comparison here is to point out that the high risk region, high risk people, the residents here in BC buy earthquake insurance. On the other hand, moderate seismically exposed population in Eastern Canada unfortunately do not buy this earthquake insurance. So my question is why? So I hope I can give some discussion on that later. Just to show the same results, but in a different format, I show the same results as in the scatter plot. So here the x-axis is the seismic design peak ground acceleration for each FSA, and then the vertical axis is the CatIQ based earthquake insurance take-up rate. And then the second figure is essentially the vertical, the axis is the same, but the horizontal axis is now annual expected loss ratio, which is a risk indicator. So we see the huge different behavior in BC and in Quebec. And then within the BC, the low hazard residents population do not buy or buy less earthquake insurance, but the highly exposed population tends to buy more earthquake insurance. And then this is just the same plot, but in a logarithmic scale. So now I just want to move on just to give a little bit more thought on how we could interpret the results I presented. So in my analysis, because I focus on the FSA level, not the individual house level, and then I showed that the income and the age profiles of those FSAs are more or less similar. So I am not be able to discuss the personal characteristic or the more detailed socioeconomic demographic profile, such as the specific opinion by the residents or the gender effect or education effect, which I don't have that data. Of course, that discussion is important, but I'm not be able to discuss that. Then for facing the low probability, high consequence earthquake risk, which might be occurring in 10,000 year, 1 in 1,000 year probability, or even rarer, 1 in 10,000 years return period level, the homeowner might have a very diverse opinion depending on the perceived risk, and then they might behave differently. So that's my kind of hypothesis, working hypothesis in understanding this two different behavior in BC and in Quebec. So from loss calculation, I can come up with the annual expected loss ratio in BC with respect to in Quebec. So if we take the range like as a rough estimate, then the risk level in BC is more or less about factor 4 higher. So, but the risk level in Quebec is not negligible. Some of the lower end of the BC residents have essentially the same risk as in the people in high risk in Eastern Canada. So there's some location which have the similar levels of hazard and risk potential. And then I was able to have a look at the some of the pricing information. So what I'm calculating here is only the pure premium. It's not the actual price which is sold in the market. But I was able to have a look at some of the those premium rates, and based on that, I have learned that the in Quebec, the earthquake insurance coverage was sold with the uniform rate, so there's no risk differentiation. So that's why I was being kind of informed. And then for BC, there's a risk price differentiation depending on the way the residents live. And there's some variation based on the data I had access to. And then based on those information, I was able to roughly estimate the safety loading factor. But this includes the transaction cost. Would be about 50% to at the maximum. Of course, this is just an estimate, but could be as large as 700% or something like that. So. And then also I was able to see that the actual insurance premium values in Quebec and BC. So I saw some article indicating that the about $200 for insurance annually is required for Quebec, and it's the $600 to $800 is required to have this earthquake insurance coverage in BC. So in BC, I saw that this $600 to $800 annual insurance premium is not cheap from my point of view. Also note that the fire insurance coverage is about $1,000. So you know, if we want to buy the earthquake insurance coverage in BC, we need to top up about 40% more. Sorry, about nearly 80% more for the insurance cost. So it's not cheap, but the people in BC buys, and then the Quebec, the price is much lower, but the people don't buy this insurance. So I also found that the interesting the consumer survey results compiled by the Insurance Bureau of Canada. So I'm just kind of citing some of the findings from the two telephone surveys conducted for the BC residents as well as the Quebec residents. And then this surveys ask a lot of wide range of questions. The perceived risk, the question related to the perceived risk, whether they buy earthquake insurance coverage, and if they buy, why, the reason. And then if they don't buy, what's the reason not to buy those insurance coverage. And then from reading from this telephone surveys results, I found that the most of the Quebec residents might be unaware of potential earthquake risk that they might face, and also some of the data indicated that they falsely assume that their basic insurance policy covers also earthquake insurance related damages. And then one of the survey results, which I show here, clearly shows that less people in Quebec was aware of the availability of the earthquake insurance as shown here. So about 40% of the people have heard about the earthquake insurance in Quebec. On the other hand, about 60% of people in BC have heard about earthquake insurance. So awareness, basic awareness level is higher in BC. And also I found that interesting results from this IBC's consumer survey results. So I'm just sharing two slides here. So the first one asks the question to the people, the homeowners who didn't buy earthquake insurance, and then given that, have you considered buying earthquake insurance? And then the respondent said that yes, I considered, but I didn't buy it. Then what's the reason in BC and in Quebec? So that shows that it's expensive. Yeah. So the majority of people thought that it might be expensive or unaffordable. And then the low risk of insurance earthquake hazard risk in the region where they live. So that's the two major answers that the respondents gave. And then also the consumer survey shows that those who didn't buy earthquake insurance, but have you considered buying earthquake insurance? And I said no. And then in that case, the majority of the people said that it's just anyway low risk of earthquake risk in my area. So that shows that the low perceived risk of seismic risk is one of the main reasons for not buying earthquake insurance. So given those, the perceived risk is low in Quebec, it might be possible to that the Quebec homeowners view the earthquake insurance as expensive and unnecessary or the unaffordable precaution. Also another interesting thing is that the take-up rates in Quebec, based on the Cat IQ data, are about 3%, and then these considered to be relatively low compared to the deductible in Quebec is relatively low, 3%. And then the same data set suggests that in BC, the deductible level is about 10%. So the BC people, even though the high deductible level, which means that if some minor earthquake happen, most of the losses has to be covered by, incurred by the residents, not by the insurers, but still they buy the insurance coverage. So that's also another puzzling part from a behavioral aspect. So I was thinking about possible solutions for this homeowners insurance gap problem. And then, of course, there's many suggestions available in the literature and in the news. And I just putting those suggestions here into one slide. So we could take advantage of risk as a feeling. So if the people see some news about the disaster, even like the current ongoing the flood hazard risk disaster happening in BC might raise the awareness about the potential risk due to disaster, and then that might motivate them to think about the possibility of buying more financial protection through insurance. And then, of course, the earthquake drills and in the public campaigns, I think it's effective, and especially I think that the earthquake drills and then also the school retrofitting program happened in BC might be useful things, because especially in the long term, because that affected the kids' seismic safety, and then the parents become more aware of the risk and they more seriously take into account. And then also in offering those policies, multi-year policies, and then automatic renewal might be considered. And also by default, opt-in and opt-in arrangement might would retain in general just higher take-up rates over the years. And then this opt-in can be used to make sure that when the people opt out, they have to click some sort of tick boxes saying that the regular homeowner package does not include this earthquake loss coverage. So that might just kind of opt-in option, and then might be considered to be effective in selling and in making sure that the residents are aware of the policy setup. And then, especially in Quebec, the risk-based earthquake insurance scheme seems to be more appropriate from my point of view, because I do see the variation of the losses at the different locations. So if you live away from the St. Lawrence, then generally the risk becomes lower. So the risk differentiation in general is more preferable, and that would suppress the effect due to adverse selection. So I would move on to the second topic. So first topic, I touched on the homeowner, and then also, but more individually at the FSA level, and then I only looked at the mean expected cost, because that's the for all homeowners what they have to pay if they sign up with the earthquake insurance. But also it's important to look at the more regional aspect, not from the homeowner's point, not necessarily from the homeowner's point of view, but from the government point of view or the insurance industry's point of view, because as I pointed out in the beginning, there's a potential risk due to the systemic collapse of the industry. So in looking at this kind of aspect, I applied the similar but the different type of earthquake insurance, earthquake catastrophe model for regional seismic risk assessment. The procedure is more or less similar, but that CAT model would include more different so the correlation of the losses for the different individual, so that we can look at the portfolio loss instead of the individual losses. So those are the major differences, but I'm not going to touch on the details of those. And then in this modeling, I was able to use the most recent Natural Resources of Canada's national earthquake exposure and vulnerability model for Canada, especially focusing on the Eastern Canada. And then in this presentation, I'm going to focus on the Montreal region because the Montreal seems to have the largest, most severest seismic risk in Eastern Canada because of the high population. Then also historically, although it's already 300 years ago, 1732 magnitude 5.8 earthquake devastated the Montreal region. So if that kind of historical events, similar events, repeat in Montreal, then the risk could be significant. And then also, as we saw in the previous slides, the residents in Quebec do not purchase earthquake insurance. So this is an earthquake insurance gap problem. And then how this risk might be distributed to the insurers and then the homeowners. And if the homeowner has to bear a large amount of risk, then what would be the solution? So that's kind of my motivation in presenting this. Yeah. And also, again, the insurance industry may fail if a large amount of risk is insured in Eastern Canada. So I have developed the stochastic seismic events over 500,000 years using the 2015 Geological Survey of Canada's model centered around Montreal, which is shown in star here. So 500-kilometer radius, all the events are taken into account. And then for each event, I have calculated the loss to a portfolio building, which I'm going to show in the next slide. So the building portfolio I considered is about 1 million buildings in which are shown in this map here. So here's the downtown Montreal, and then it's highly concentrated. So this is the building number, essentially representing the building population or the population density. So high population density in this downtown Montreal. And then I considered about 1 million buildings, and then but I only considered wooden frame building. Yeah. This is about the wooden frame building is most popular building forms in Eastern Canada. So based on the NLC CANS database, about 92% here is wood frame building. And in terms of the total asset, which roughly captures 53% of the total building asset value. So the other half coming from the reinforced concrete building, which is not considered in my calculation. And then those are mostly probably commercial building, and also the rented, the residential building. So in my calculation, I considered about $744 billion in asset for just 1 million building houses. And then for my calculation, I can split the loss, physical loss, into the insurers and in the non-insurer homeowners. So in doing that, I have used the CatIQ insurance take-up rates, which is 3% regionally. So if I run the loss calculation for 500,000 years, and then if I pick all the losses which exceed portfolio loss exceeding $1 billion, yeah? And then those are spatially shown on the map. And then the color represents the portfolio loss amount. So some of the losses, if happens very close to Montreal, downtown Montreal here, then because of the high exposure of the region, it could lead to tens of billions of dollars potentially. So in the context of the systemic risk, the color representing blue, green, yellow, red might be potentially a concern for insurance industry if all the costs are covered by the insurance industry, which is not the case for the current situation. Also, I can obtain exceedance loss curve for this Montreal region by considering the 500,000 years of stochastic events. And then this is shown in linear form or a log form. So it's essentially the same results. And I can split the total cost for the total cost or the owner's cost, which is in red, and then the insurer's cost. So insurance cost is low because in my calculation, I only considered 3% of the losses would be covered by insurers. And so that means that 97% of the homeowners are uninsured. So we can read those figures, graphs in a different way, and then we can obtain a lot of interesting information. Just as an example, if we are interested in, say, $10 billion loss level, then we can say that this loss level for the homeowners or the total population might happen about 1 in 1,000 years return period level. Or we could say that the typically PML, probable maximum loss for the earthquake loss is set to 500 years return period level. So if we look at that level, then the expected loss might be around $5 billion or something like that. So we can obtain a lot of information. I was also interested in given a particular loss level such as this, then what would be the expected shake intensity, and then which is shown here. So this spectral acceleration in terms of gravity is shown here. So that is the map is showing the intensity of the shake. And then the bottom figure is that for each individual FSA, what would be the loss experienced in Canadian dollars. And then if we sum them up, then that leads to the portfolio loss, which is about, for this case, at the 500 years return period level, which is calculated as $4.7 billion. And also you see a diagram like this. So we can divide this $4.7 billion, how this is shared by the two different stakeholders. So we can divide that into the homeowners, which is in blue, and then also the insurer's loss. So that's for 500 years return period level, and we can do the same for 1,000 years return period level. So for this case, the scenario event happens relatively near to downtown Vancouver. Sorry, no, downtown Montreal, and then the significant shake is caused in the southern part of Montreal, and then the loss is again high. And then both the public's financial exposure and then the insurer's exposure has increased. And then we can do the same for 2,500 years return period level. So we can continue this for whatever levels we are interested in. So having those results, I had some thoughts on possible solutions for dealing with this catastrophic earthquake risk, especially for Quebec. This is not my final thoughts, and then this has, developed. I came up with this kind of idea through the active discussion with Paul, Howard, and other people as well. So I just want to summarize those, and then I would want to end my presentation in 2 slides. So in Montreal region, say Quebec, financial risk exposure for homeowners are high if earthquake, catastrophic event happens. This is because of the high exposure. So many people live, so many vulnerable buildings exist. And then there's a little financial protection for homeowners through private insurance because of the insurance gap problem, as we saw. And then in that case, I could guess that if some significant event happened, then the public assistance may be inevitable in that case, some sort of disaster financial assistance program may be exercised, implemented for such purposes. That indicates that the financial risk would fall upon taxpayers in one way or the other way. So one possible solution, this is again still a general kind of idea, but how the earthquake risk can be dealt with currently is not ideal because the people are unaware of the seismic risk, especially in East, and then people might be expecting that the government would help if something significant might happen. And then because of that, the seismic risk are not transferred effectively to private market insurance, as shown by the low take-up rates. So in general, in various areas, we know that the ex-post approach after the disaster are known to be inefficient compared to the ex-ante approach, so be prepared approach. So we might want to change this kind of attitude from the ex-post to ex-ante. And then Canada definitely needs a solution that solve the earthquake insurance gap problem, and then also the systemic risk problem, especially for East, because potentially the loss can be significant. So some sort of government's kind of backstop might be necessary for very severe events that affect the whole Canadian insurance industry. So in nutshell, I think that I don't have any specific solution here, but I think that the multiple actions from various stakeholders in a concerted manner are definitely necessary, and then that's how we think that we should move on to fix those problems. And then that's the end of my presentation, and thank you very much for listening.
All right, well, thank you very much for that presentation, Dr. Goda. It was both interesting and somewhat terrifying. We have a couple questions to start here. I'm going to split them up into questions about modeling and questions more about the results. So I'll start with the modeling first. First question comes from anonymous attendee. And was the modeling including both physical and social vulnerability?
Yeah, so my calculated results only touch on the physical and then only the shake results. So in that sense, my estimate is definitely the minimum, the lower end. And then, like, as you point out, that the other risk, like such as fire following, geohazard risk that are not included, tsunami risk is not included, and then also the social vulnerability part is hard, very difficult to quantify, but and then also it's not included. So that's definitely a future direction that we should try to incorporate. So I would say this is my estimate is the minimum.
Okay, thank you very much. Another question here from Peter. Hi, why didn't you use, for example, OpenQuake, in which the 6th generation of SHMC is developed and could be combined with vulnerability?
Well, at the time like this kind of investigation started, this information was not available. Now I understand that it's available. And then the vulnerability model and then the exposure data set was obtained from the NRC CAN's team. That means that essentially some preliminary versions of the OpenQuake. So the information that went into my calculation is somewhat similar to, not necessarily exactly, but similar to what is there in OpenQuake. And then the other thing that I just want to add is that I do coding everything by myself, and then it's much quicker for me to do different thing. And then also, I not just seismic, but I also do liquefaction, other things, the landslide. Those are things I'm interested in, and I want to include in a flexible way. So OpenQuake yet do not provide this kind of multi-hazard aspect. Tsunami is another one. I'm working on those to be included and integrated. And then for research, it's quicker and then more flexible to do in my way rather than following existing platform.
Okay, thank you. I have a question here about the comparison to the 1994 earthquake in Northridge, and it's just asking, given that Quebec was dealt much earlier than Los Angeles, is the urban form of the 1994 Northridge earthquake comparable to Montreal?
So the vulnerability compared is for specifically for the BC. And then the results I showed for especially for the Victoria. So the Victoria I considered it's in the west, and then the California it's more or less similar. I didn't have time to mention in detail, but the when I developed the vulnerability model, I as I said that I did the analytical way. And then I did a lot of nonlinear dynamic analysis as a part of this calculation. And in doing that, I have selected the suitable ground motion for the local hazard. So in other way to say is that my vulnerability model for Montreal reflect the seismicity in Montreal, and I selected the ground motion in such a way, but it just it's not mentioned in the presentation.
Okay, all right, thank you very much. And I'd just like to remind people that we do have until 2:30 to answer the questions. So if you do have anything in mind, just drop that into the question and answer box and we'll get right to it. I have a question here from Tegan Hobbs. Can you comment on how your 500-year loss, the 4.7 billion in Montreal, compares to other estimates, like the tens of billions expected by the AIR 2013 report?
Well, my understanding for Tegan's question, my understanding is that AIR's report is the scenario based, so they do not consider the occurrence probability. So I cannot directly comment on that on this, but I also have done kind of reproduction of what the AIR the results. And then what I found is that if I use their source model in my way, based on my expertise in seismology, my mean expected loss for this shower loss scenario for the same magnitude, similar geometry of the fault would be much, much less. But my upper end of my estimate would definitely cover that $60 billion losses. But that's, to me, might be a bit extreme situation, but again, that difference could come in various way. So I wouldn't say which one is right or wrong. Like there's a lot of uncertainty associated with any of the model.
Okay, thank you very much. Another question here. Can you give an estimate as to what losses in Montreal would be if concrete buildings were included in the model as well?
So can you say it again, please? Sorry.
Could you give a possible estimate or a guess, I guess, as to what losses would be in Montreal if concrete buildings were included in the model?
It's hard to guess because I haven't done the calculation. But in my opinion, I think that as long as modern reinforced concrete structures, I think that the loss would be less relative to the wood frame building, which is not seismically designed. But still, I would think that the reinforced concrete structure, especially relatively low rise, might have some significant risk. But the high-rise building, unless they are on the very soft soil, then the natural vibration period is generally off from the peak frequency contents in Eastern Canada. So in that sense, the RC building in relatively high-rise RC building in Eastern Canada might do well. That's what I think.
Okay, thank you very much. another question here, and this is running low on questions right now. So if anyone has any more, feel free to drop them in there. Well, BC's rate is higher than Quebec. Is the insurance take-up sufficient, or should there be a decrease to increased rates there as well?
Well, I was very excited when I found that this 50-60% of the people, residents in BC, actually buy earthquake insurance, knowing that for example, in California, I think that the take-up rates is about 10 to 20%. I'm Japanese, so in Japan, like maybe 20 to 30, at most 40%. So I was surprised that it's a voluntary earthquake insurance policy, and then the people in BC are so aware and then protect themselves. So that was really exciting kind of finding. But of course, we should aim for 100%. But that might not be possible.
Okay, well, that rounds out all the questions I have in the feed here. So I would like to give a big thank you to Dr. Goda for taking time out of his busy schedule to provide us with that informative and interesting presentation. And I'd also like to thank you in the audience for joining us today and providing us insightful questions. If you're interested in recording of this session, it will be available on the ICLR website and YouTube channel shortly. Also, please join us next month for December's Friday Forum, which will be titled Development, Responsibility, and the Creation of Flood Risk in Calgary, Alberta. Thank you all for attending, and I'll let Dr. Goda have the last word before we wrap up. Thank you.
Thank you.